a bunch of operators over here. Question, which of these operators are Hermitian? Pause the video to ponder this. So quick recap of the definition of a Hermitian operator. Basically means that if we have our operator first operating in the scalar product on the first factor, and then taking the scalar product, that this situation is identical where the operator first operates on the second factor of the scalar product. So if this is the case, then we have a Hermitian operator. Let's now have a look at the three operators we have there. The first operator is the rather boring identity operator. So let's plug this in our equation. Now the scalar product, in this case, we have defined that as a volume integral of our first factor. So that's going to be the unit T operator operating upon F. And then we have the complex conjugate in our definition of scalar product. Then we have the following integral. Question, is that equal to the situation where we just have the complex conjugate of F, and then we have the unit operator multiplication by 1 operating on the second factor. Obviously, because this is just the unit operator, nothing changes. These are indeed the same, and this is a Hermitian operator. That was a rather trivial case, slightly less trivial, still pretty straightforward. What happens if we replace multiplication by 1 by multiplication by j? Then the situation becomes different, because as you see, now what happens is that on the left hand side j is under a complex conjugate sign, whereas on the right hand side that's not the case. So there will be a minus sign between these two situations here. So these are not the same, and therefore multiplication by j is not a Hermitian operator. Finally, we have the curl operator. So again, our volume integral curl of f complex conjugate g dv. Well, the del cross operator or the curl operator just takes partial derivatives. So there's nothing related to complex conjugates there that could affect it. So we can rewrite that as such that the complex conjugate operator only operates on f. So that's the curl of f g dv. Next step is to look up something in the textbook where we've seen a formula to move the curl operator basically from the first factor to the second factor. And in the course notes, we've seen that you can indeed do that. You can replace that by the following, just moving the del cross operator to operate on G. But the price you pay for that is a surface integral of some stuff. So it's not exactly the same. There's this extra term here. However, in most situations, we're going to say that this term is 0 because of what happens at the surface, at the bounds of your volume, for example. Either at infinity, the fields are 0 or are periodic and therefore cancel. So we're going to say that this term, we can neglect that. We can put it identically equal to 0. And then you have the situation where the two requirements are met. So either you first operate with the curl on the first factor, or you operate first on the second factor, and they are identical. So in case you can neglect the stuff at the boundary, in case the stuff at the boundary vanishes, then this is a Hermitian operator as well.